Okay, in this video we're going to talk about graphs of polar equations. This is found in section 10.8. Basically, with most polar equations, like this example here, r equals 4 sine theta, we're not going to try to change it to rectangular coordinates. You usually want to graph in polar coordinates. And the most basic way to graph anything when you first get started is the method of plotting points. So we're used to a table with x and y and pick an x value and substitute it in and get the y value. For these, you want to pick a theta value, an angle. So I've got some sample theta values. So if you were to use 0 into this equation, you'd have to do r equals 4 times the sine of 0. And the sine of 0 is 0, and then 4 times 0 gives you 0. So there's a point where r is 0 and theta is 0. So remember, the points are r theta. In this case it won't matter because they're both the same number. So then if we graph this, there's a point at 0, 0. Okay, then if we go to pi over 6, then we're going to do r equals 4 times the sine of pi over 6. So that'll be 4 times 1/2. That'll be 2. So when theta is pi over 6, r is 2. So that's the point 2 pi over 6, because it's r and then theta. So if we go out at an angle of pi over 6, then we go out 2 units. 1, 2. All right. If we do pi over 3, 4 times the sine of pi over 3. That's 4 times the square root of 3 over 2, which I'm going to go ahead and approximate it since I'm graphing. So about 3.5. So 3.5 comma pi over 3. So that would be this one here. So 1, 2, 3 and a half. All right, pi over 2. The sine of pi over 2 is 1. So 4 times 1, that gives me 4. I have 4 comma pi over 2. 1, 2, 3, 4. So you can see it's been going like this. Okay. And then 2 pi over 3. That's going to be 4 times the root 3 over 2 again. So I'm going to get another 3.5. And then when I do 5 pi over 6, that's going to work out to be 4 times a half again. So I'm going to get 2. And then here I'm going to get 4 times 0. So I'm getting repetition of values there. Okay, well, that just means we have some symmetry. So 2 pi over 3, about 3.5, and 5 pi over 6 was 2, and then back to 0. All right, so we're getting this shape. It's actually a circle, though it's kind of hard to tell from my graph. Now, if you keep going, if you were to do 7 pi over 6, you'll see that's not really necessary. So the sine of 7 pi over 6 is negative 1/2. So you'll get negative 2. So there's a point at negative 2 comma 7 pi over 6. All right. Now that's the same thing if we change it to positive 2. Remember, you can change r to the opposite value, and you could add or subtract pi. So if I subtract pi, it brings me to pi over 6. That's this point here. We already have it. Right? If you go to the angle of 7 pi over 6, but you go negative 2, that means 1, 2, you're here, right? So once we've done from 0 to pi for this particular equation, we've plotted all the points. Okay, so this one works out to be a circle, okay? This distance here is 4, so, and the center ends up being here, and the radius is 2. That's how that works. There are techniques to learn symmetries to save yourself time, and there are some basic polar graphs that people can learn. We're going to learn these things using Desmos, D-E-S-M-O-S. All right, and you don't need to do an account or anything complicated. If you just hit start graphing, you come up with this screen. So over here, you're going to type your equations. You have all kinds of menus down at the bottom. Some are hidden, some are there. So if we just do the one we just did, r equals 4 sine theta. So I have to hit ABC to find the r, and then the equals 4. Now you can go back to the ABCs and type sine if you like, or you can do this functions and pick sine. Either way will work. Theta, you have to hit ABC to find it. It's over there. There you go. Okay, so it's got it graphed before you even finished. And it does have where it's drawing it. It's using the points from 0 to pi. All right. And of course, you can make things bigger, smaller, pinch them. If you hit the little house, this should go back to the original home screen size. Now, if you don't want to see this anymore, but you need to save the equation, you can just tap on the little circle and it's still there. Because I'll have you take some pictures of things, but you could save it. If you go back to your equation and then hit enter, then you could type in another one. Now, if I did, just to show you another cool thing that Desmos does, r equals, and let's not pick 4, let's just type the letter A. If you pick some other random letter, it will know that that's supposed to represent different values. Right, and okay, so here's what it does. It says add slider, and so just click the little A, and now there's a slider. All right, so it has a graph for A equals 1, but you can just take this and just change the A values with the slider. So if I go, well, there's 5. All right, so now it's graphing A equals 5, 8.2. All right, you could do negative A values. It ends up just making the circle on the other side. So this is a way you can quickly explore what happens with different values, which you will use in your practice problems.